Insertion sort involves inserting an unsorted element among a set of sorted elements. So we're gonna write a variable called p, which will point the position that we may potentially insert the unsorted element. Okay, and we're gonna use a variable called m, which will mark the unsorted element that is going to get compared. Initially, the sorted part consists of just the first element and expands to eventually encompass all the elements of the dataset. So for n elements in the dataset, we're going to use a variable called position after sorted set, which will start at 1 and it will go till the element just before n, which is n minus 1. So we're going to write a for loop, okay, a for loop which has in a variable called position after sorted set that will start from 1 and it will go till the element right before n, which is n minus 1. Now, since element at position after the sorted set, which is our variable, is what we are trying to insert at the correct sorted position in our, and that unsorted element is going to be saved in our pre-designated variable m, we are going to set m to the element that is being pointed by position after sorted set. So we're going to write m is equal to data of, or we're going to use the index of position after sorted set. Also, since the position where we may insert m initially is the position after the sorted set, we need to cache that in our predetermined variable p. So p is going to be the position after the sorted set initially. Now we search for the right position by comparing m with elements at positions before it. And we stop our comparison when we find a sorted element smaller than m, or if we reach the start of our dataset. As we compare m with elements before it, we shift all the sorted elements greater than it to the positions to the right. Because as you know, in a sorted set, the biggest elements are towards the right and the smallest elements are towards the left. So as we keep comparing m with the elements before it, we shift all the sorted elements to positions to the right if those elements we're comparing it with are greater than m. Okay, so that will lead us to our while loop. So while m is either less than or equal to data of p minus 1 and p has to be greater than 0, then that means that our m either is at a position greater than 0 and our m is smaller than whatever the position p minus 1 is pointing to. So because our m is smaller than whatever the element p minus 1 is pointing to, we will shift that element at p minus 1 to position p. So that will lead us to data of p is equal to data of p minus 1. So we shift it to the right and then we decrement p. So we keep moving more and more towards the starting of our data set. So basically we're shifting the elements to the right and we keep searching on the left if there is any other element which is smaller than m. And when we exit this loop, it's either because we found an element smaller than m or if we reach the starting of the element. So that is the position where we want our m to be inserted. So that will lead us to data m being inserted at position that is being pointed by p. So that's what we're writing, data of p is equal to m. Well, not of p, but the position in data which is being pointed by data. The position which is being pointed by p is where we're going to insert m. So that will conclude our code and we're going to close our outer for loop and that's the end of it. So as you as you see, there are two critical things in insertion sort. One is the assumption that some part of the data is sorted, and the second thing is the assumption that the attempt to keep to position the unsorted element among the sorted elements by comparing it with every one of the sorted elements until we either reach the starting of the data set or we encounter a sorted element which is smaller than the unsorted element we are trying to insert. So the sorted set expands to the end of the data set with each iteration. That's indicated by our for loop, and the condition which I just discussed, the second condition, which is either shift the elements to the right if m is smaller than it, or and keep doing that until the position we're trying to compare with positions the element at position 0. So that's indicated by our while loop, and that's how insertion sort works. So insertion sort is really great to sort elements which are partially sorted. So if we have a set like which is previously sorted by some technique, and now we're trying to insert an unsorted element to it, insertion sort is a great thing because all it needs is like one parse through all the sorted elements and it'll find its position, and that's a great thing because you don't need to really sort or iterate over the already sorted elements. So insertion sort takes care of it. And the efficiency of insertion sort, tau is O of n square. It's much more efficient because we're not doing as many shifts as we would do in other kind of sorts. So that's all, guys. So insertion sort is a great technique and it's used by many other advanced sorting things, so it's a good thing to know. It's a good thing to remember, and I hope you guys like this video. So just leave it in your comments, whatever you have to say. Thank you.